Good evening, everyone, and welcome to our third virtual community meeting. We're so glad to have you here with us this evening, whether it's your first time joining us or your third time joining us for this virtual series that we launched after a series of in-person meetings and certainly during the time of COVID. So we're glad to keep this tradition going and look forward to sharing project updates with you this evening. I'm Shannon Debus. I'm local to the area, graduated from Geneva College, and have been honored to serve as your community liaison for the past 10 years. Tonight, I'm pleased to introduce you to our team, and then we'll share a safety moment before we get started in the presentations. So this evening, we'll have our General Manager, Bill Watson, sharing with you a project update and an overview. Our Production Manager, Michael Burke, will be talking about flaring and rail activity as we go into operation. Our Environmental Manager, Kim Kale, will be providing an environmental update for you. And Mike Mitchell, our Emergency Services Coordinator, will be sharing a bit about our emergency services on site. So all of the information that we'll be sharing this evening is really coming from your questions and what you brought before us. So we're really pleased to pull this information together. But we'll begin this evening in the same way that we begin all of our meetings on site with a safety review. So we do ask that you please not take this call while driving, even when using a headset or hands-free. And when you are using a headset, please make sure that you can hear everything around you, be it a fire alarm or something else that may alert you that you need to leave your location. We also ask that you be aware of all of your emergency exits and what's available around you, as well as any first aid kit should you need it. We also ask that you please keep your microphones on mute and would like you to know that you can submit your questions at any time by typing a question in the chat box. And if you find you do need to step away from the presentation, no worries, you won't miss anything. We're recording this for you, so you'll have an opportunity to watch it later. And so with that, I'd like to introduce our General Manager, Bill Watson, to share with you our project and asset overview and update. Bill?
Thank you, Shannon. And thanks to all of you for joining this evening. Again, my name is Bill Watson, and I'm the General Manager of the Shell Polymers Monaca facility. And I just wanted to start out by reminding you how our site is set up. And so Shannon, if you could go to the next slide. We'll give you a quick overview of the site. Here we go. So this is an aerial photo of the facility. I'm going to start at the top left of your screen there, where you can see our raw water and our wastewater treatment plant. So here we take water from the Ohio River, we clarify it, we filter it, and then we send it to our cogeneration unit, which is kind of in the middle of your screen, in the middle of the facility. There we further purify it, and then we make steam and electricity that powers our plant. Now, on a normal day, we'll export about a third of our power generated. That's about 80 megawatts of electricity that's sent to the grid. And that's an equivalent to power about 52,000 homes. So the next area I want to talk to you about is our ethane cracking unit. That's kind of in the top, still to the left of your screen. And there we take ethane and we crack it to make ethylene, which is the building block that we use to make our final product, which is polyethylene. And that is produced in one of our 3 polyethylene units, which are kind of in the middle right of your screen. So we make over 40 different grades of polyethylene, and all of that will be shipped over land, either in rail cars or trucks. And you can see we've got lots of rail on site. Michael's going to talk more about that here in a bit. You can see if you look on the screen, we've got I-376 that runs through our facility. To the right of that, quite a few miles of track there. We also have our rail maintenance building on that side of the facility, as well as our rail wash building. Now, a couple of other key areas to note are our cooling water tower, which is to the top kind of middle of your screen, as well as all of our site buildings, which are located toward the bottom of your screen. And those include our administration building, our maintenance building, our warehouses. We've got our innovation center. I'll talk to you more about that in a bit, as well as our fire and medical building. So just a brief overview of our facility again for you. So if we go to the next slide, we'll give you an update on construction progress. So we're now approximately 95% construction complete, and we've got about 4,000 construction professionals that remain on site. Now that's down from our peak of about 8,500 construction professionals. And as we continue to finish construction of the plant, we continue to ramp down on the construction personnel, ultimately getting to our about 600 full-time employees that we'll have to run and maintain the site going forward, as well as our contract support. So if we go to the next slide, Shannon, I want to talk about steam blows and air blows. So both our steam blows and our air blow programs are now complete. Really want to thank the community for your support, your open communication during those programs. Now, it was mostly quiet on site and in the community throughout the programs, though at the very start of both, we did get feedback from the community that the startups were a bit loud. So while those fell within the regulatory limits, we did hear your concerns, and based on your feedback, we were able to make some engineering and some procedural adjustments that we also got your feedback on that confirmed that those were effective. So really appreciate that. And thank you for the ongoing dialogue. That's going to be critical for us for a successful startup. And speaking of community notifications, we preview our activity on Facebook, and anytime we believe an activity may have the potential to affect the community, whether by sound or sight or otherwise, we share that with you, and you can see a copy of our Facebook page on the slide in front of you on the right. Now, if any unplanned activity occurs, we'll also communicate with you on any matters that may potentially create an off-site impact. Now, some questions arose recently regarding the sulfuric acid spill that took place back in March on site. Now, that spill resulted from a faulty flange, and it was found during an operator round. It was fully contained, and it created no off-site impacts. Now, we do have systems in place to manage that type of potential incident, and they did work exactly as they were supposed to. So the health of the safety and the welfare of our community, it's really at the forefront of everything that we do. And you'll hear more about how that care for our people is built into our processes from our leaders as they speak here this evening. So if we go to the next slide, Shannon, yes. So I want to talk a bit about our flare pilots. So we lit our flare pilots back on March the 22nd, and we made an announcement on Facebook at the time, and we recognized the community had a hard time seeing the pilots. We actually had a hard time seeing the pilots as well, which is good. Now, the picture that you see here in front of you is an infrared snapshot of the high pressure flare pilots, as well as of our ground flares. So you can see them on your screen. They are lit. And so just wanted to share that with you. They are indeed lit, and they're working as they're supposed to. And Michael is going to talk a bit more about our flares in his presentation. So if we go to the next slide, Shannon. I did want to talk to you a bit about our innovation center. So we've had a number of developments on site as we get closer to commissioning and startup. And that includes inside our innovation hall, which is one of the buildings that I mentioned earlier. Now, we're going to share more about our innovation hall in future meetings, but it's a special facility for us because it allows our customers to come to site and actually work with us to design new products for their customers or to troubleshoot issues they may be having. So you often see, on the outside of what's going on and what we're doing, but this offers you an opportunity to see what's going on inside. And the Innovation Center is special because we have a lot of the same equipment that our customers have, and we can make the products that they make, again, to help them improve their products. So you can see here in the picture, we made some 5-gallon pails in the building, and some of our team members are holding those up. And just to kind of wrap up at a high level from a commissioning and startup perspective, we've handed over the majority of the buildings on site, and we've also commissioned really all of our utility systems. So our cogen unit that I mentioned, it's up and running, producing steam and electricity, and we're moving further into the commissioning of our ECU and our polyethylene units. So the last slide I'm going to cover with you here is around carbon capture and storage. So Shell is supporting the energy transition through our strategy, which we call Powering Progress. And we strongly support efforts to develop carbon capture and sequestration, or CCS, as it's abbreviated there, opportunities. Now, ultimately, Shell's target is to become a net zero emissions energy business by 2050, if not sooner. And we're committed to helping decarbonize the tri-state region by working with our alliance partners and local and state government leaders to define a shared vision for a low carbon and hydrogen industrial hub in Pennsylvania, Ohio, and West Virginia. Now, CCS is one potential component of a broad solution, and we're excited to be a part of that solution. And with that, I'm going to hand over now to our production manager, Michael Burke, and he's going to give you an update on flaring and rail activity. Michael?
Hey, thanks, Bill, and good evening to everyone on the line. I'm Michael. I'm the Polymers Production Manager. In this role, I have operational responsibility for all of the daily tasks that take place on the site. I've spent nearly 20 years with Shell at petrochemical facilities throughout the United States. And I'd like to start with an overview of what flares are and why they're necessary. Go to the next slide. There we go. So what is a flare? It's essentially a vital safety device and an environmental control. And I say that, and it's a safe way to burn hydrocarbon gas versus release it directly to the atmosphere. And in doing that, it protects our community and protects our employees. In essence, at the fundamental, it's very similar to a gas grill or a natural gas stove that you may have in your house. And the combustion products from this flaring of fuel is mainly carbon dioxide and water vapor. And our intent, our purpose, our objective is to minimize the use of flaring to the extent possible. And to that end, we formalized a flare minimization plan. Our flares are predominantly used during startups and shutdowns, and also for unplanned operational interruptions. And if I can make an analogy, you can see the hot water heater that I have in the top right. If you've ever maintained your water system in your house, if you ever had to replace a faucet or a fixture and drain, you've probably drained that water to a bucket or to an actual drain that goes outside. If you've ever replaced a hot water heater, I know that's not a fun thing, but I've had to do it. You have to drain it out, and then when you put the new one in, you probably flush it a few times. And then there's this little device on the side. It's a pressure relief valve, and that's there to protect your home and your family if the hot water heater overpressures, and it relieves water down to the drain. And so we have essentially the same systems at our facility. The major difference being we don't have water. We have ethane and ethylene, and we can't simply drain that to the ground. So if we shut down or start up a unit, if we do maintenance, or if we have an unplanned upset like that relief valve lifting, then the hydrocarbon is routed to the flare where it's most efficiently deconstructed and minimizes the potential for a release to the atmosphere. So on the next slide, we'll take a quick look at where the flare systems are around our facility. So on the left or to the west is our high pressure flare system. It's most visible with our elevated flare, but there's more equipment there as well. And then on the right or to the east is our low pressure system. So let's start with maybe a look at the low pressure flare system on the next slide. So the major piece of equipment in this system is what we call the multi-point ground flare. And the shielding around this flare does tend to make it look like a set of stadium bleachers. But inside those that shielding are three headers. And those are what combust low pressure gas if it's required. So flow to this flare is not continuous, and it only occurs during certain operational conditions, even though the pilots always will remain lighted in order to receive flow if it's required. Let's maybe take a peek at the high pressure flare system. So there are two major pieces of two major components in this system. One being the ground flares and one being the elevated flare. The ground flares, those are the two metallic cylinders you see in the picture on the left. And the way our system is set up, that if there's a need to flare, the initial flow will be routed to the ground flares, and that minimizes the usage or eliminates the usage even of going to the elevated flare. And the benefits of those ground flares, they have an increased capacity for smokeless flaring that's based on their engineering design. And then due to that shielding that you see around them, there's less light emitted, less sound emitted from these two ground flares. And for the majority of our startup, we expect that any flaring required is contained within these ground flares. The elevated flare to the left, it's approximately 370 feet tall. If you look at the picture on the right, that's actually the top of the flare where a flame would be emitted, and that's what we call the tip. So the way our systems work is that flows are automatically routed from the ground flares to the elevated flare when the capacity of those ground flares is reached. And we elevate that and put it up high because that is a higher volume of flow, and that helps alleviate the concerns we have with the safety of our personnel on the ground and those around the area if it's required to use the elevated. So let's maybe take a peek now at what you can expect to see or hear from usage of the flares. So I'm going to start with, these are not pictures of our flare. Obviously, if you've taken a peek, these are from industry. But a couple of things to note here, what you may see. So as Bill mentioned, the pilots are always lit. When there's gas to the flare, you'll see a flame from the tip as the two pictures on the right, and that flame will vary with flow rate. There'll typically be a plume of steam that's not smoke that may be emitted from the tip of the elevated flare, and that steam is actually used to ensure the conditions exist for complete combustion, and that actually helps to minimize smoking if a significant flow is required to the elevated flare. That said, there are conditions that could create smoking for a limited time at the flare. That smoking is a sign of incomplete combustion, and then operationally, what we do at that point is we take action to minimize that. And so that could be adjusting the steam rate to create a more proper atmosphere for combustion, or and simultaneously reducing the flow to the flare itself. And for certain situations or conditions at the site, we do actually have automatic controls in place that will rapidly reduce the feed to the plant and therefore the associated flaring. From an audible perspective, elevated flare may result in a low rumbling sound, and that's due to the turbulent mixing of steam, air, gases at the tip of the flare. And again, similar to the visual cues, we take action to eliminate that. So we definitely appreciate that the light and the sound have the potential to impact our community. Again, the majority of the time, we should only see a visible steam plume. It's important for us to minimize the use of flare when possible. We definitely understand that. But there are scenarios where the use of this elevated flare is necessary to keep our community and our operations and our employees safe. I'm going to skip now to our rail facility. And with that, share just a brief overview. So as mentioned earlier, the facility extends the full southern edge of the site, passes under I-376 to our east rail yard on the east side of the interstate. Internally, it's maintained and operated by Shell Polymers in conjunction with our contract partners. And then we maintain connectivity to the broader regional and national rail system via CSX. We have many, many miles of rail on the site. Our plans include about 80 cars per day moving in and out of the site. We have storage for 1,600 cars. And you'll see two main types of cars. One are hopper cars. So those are the more rectangular rail cars. That's the vast majority of the fleet that we'll have on site, and those are intended to move polyethylene around. We fill those with automatic loaders, and they can fill one of those cars in about 25 minutes. The other type are tank cars, so those are cylindrical. These are for inbound co-monomers, and those are components that we mix with the ethylene to make polyethylene, and then outbound cars for our hydrocarbon co-products that we make in conjunction with the ethylene. And now go to the next slide and share a little bit more around activities in the rail yard. So some of the major activities, we move cars around just like any other rail yard. We stage them to be ready for loading, to be removed off site. We actually conduct loading and offloading of both tank and hopper cars. We do minor maintenance of cars on site, replacing a wheel, a bearing, touching up a liner inside a car. And as Bill mentioned, we have a wash facility. When we receive used cars back to the site, hopper cars, we wash those. Any debris is screened out, and then we recycle the water back around to wash the next car. Another key component I know is a big one out there is noise. And there are several things that can cause noise in the facility. I'll talk those real briefly and then talk about what we're doing to mitigate that noise and its potential impact on the community. Coupling of cars, so physically joining them together, the noise of the engine from the locomotive, squealing of wheels as it moves around the track, and the horns, which are a necessary safety feature to protect our personnel in the yard. Those are all things that can cause noise. So what are we doing? Our coupling will take place at a very low speed. It'll be less than 2 miles an hour. And we also won't use the practice of free rolling or shoving cars down the track where they uncontrolled bounce into another car and lock that coupling in place. Half of our rail car movers are what we call track mobiles. So they're much smaller engines. We use those for about half of our movements. When we have fully loaded rail cars, though, the full-size locomotive is required. The speed limit is 7 miles an hour, so it's actually a very low speed limit for a rail yard, reduces locomotive engine noise. We're working to reduce our horns to the lowest allowable level under the Federal Railroad Administration guidelines. But again, it's a safety device that's there to protect our employees. We plan to reduce the number of crossings after construction is complete. That minimizes the use of the horn in the first place. Our team sounds that horn in a brief 1-second blurt relative to a multi-second long blast that you may hear on a highway crossing. We've reduced night activities. We're not planning to completely eliminate night activities, but where we have discretional activities or we can optimize, our intent is to reduce the amount of activities that happen after hours. And then lastly, the rail yard was built with engineering analysis and studies and models. Now that we have hopper cars on site, we're moving them around. We're in a position that we can collect more data, and we've actually initiated that. Our intent is to continue collecting that data in the coming weeks and months, to continue analyzing that from an engineering perspective, and to determine if there are opportunities for us either via administrative or what I'll say operational controls or engineering controls work to reduce the impact that noise could potentially have on our community. So thanks everyone for the time. I appreciate discussing these two aspects of our operations, and I'd like to hand it back to Bill to maybe share a few additional remarks.
Hey, thank you, Michael. I just wanted to mention that when it comes to activities on site that the community may see or hear or otherwise, that myself, like many of our employees who work on site, we actually live in the local community. And in fact, I can see the plant from my house. So not only do we care about the community because we're a good neighbor, but we also care about the community because we are your neighbors. And with that, to talk more about environmental and where we're at with the site plans, I want to introduce our environmental manager, Kim Kale, and she's going to give you an update. So Kim?
Hi, I am Kim Kale, Shell Polymers Environmental Manager. I'm really happy to be with you here tonight. I've been in the environmental field for over 30 years and with Shell 11 years, and this project brought me home. My family's originally from Coraopolis, just up the river. I grew up in Pittsburgh. I was educated here and my family's still here. Protecting the community and the environment is our top priority. Our plant incorporates best available technology, which minimizes emissions. We permitted our plant working with the state and the federal agencies and operates under some of the strictest requirements in the nation. Now, Michael covered our flare hardware, its purpose and function, and I will explain more about the environmental requirements and how we monitor and control our flares. As noted, our flares are a safety device, but they're also designed to minimize emissions. One way is through our high pressure flares, shown on the left, and the other way is through our low pressure flares, including the thermal oxidizers, and a multi-point ground flare as a backup. Our flare systems are designed to achieve at least 98% destruction efficiency and 99.9% destruction efficiency for thermal oxidizers. Our plant is also designed to recycle hydrogen so that we burn less natural gas, thereby further reducing emissions. We have a flare minimization plan. It was reviewed and approved by Pennsylvania Department of Environmental Protection, or PADEP. It references startup procedures and also describes corrective actions that could be incorporated in the event of unpredictable circumstances. Our flares are also equipped with analyzers. They measure the content of volatile organic compounds, methane, carbon, and sulfur. Each flare also has a video camera and a recording system for monitoring them on a full-time basis. We also monitor for visible emissions. Each flare uses the combination of analyzers, flow meters, and engineering calculations to ensure the heating value is sufficient for the destruction of hydrocarbons. We permitted our flare emissions using regional ambient air modeling. The stars on this slide indicate locations where stack testing either has or will occur. Continuous emission monitoring systems, or CEMS, monitor emissions from our furnaces and our cogeneration units. Our CEMS monitor for carbon monoxide as well as nitrogen oxides. Stack testing already has occurred and is completed in our cogens, and it will be conducted in the future at our furnaces, our thermal oxidizers, our pellet dryers, and our catalyst activation vents. Stack testing assures our emissions. They provide our emission factors for our calculated emissions submitted quarterly and in our annual inventory. It allows us to certify the accuracy of our CEMS. It also, more importantly, allows us to demonstrate compliance with our permit limits. Stack testing is performed after startup and repeated as required by our permits. The tests are performed using Environmental Protection Agency methods. A little bit about our fence line monitoring program. We have implemented a fence line monitoring program to monitor for volatile organic compound emissions. The fence line monitoring program was designed using EPA standards in collaboration with both the Clean Air Council and the Environmental Integrity Project. Passive air monitoring systems, or PAMs, and continuous air monitoring systems, or CAMs, were installed to monitor emissions at our fence line. There are 20 PAMs and 4 CAMs, all located in both the upwind and downwind directions. PAM samples are collected for VOCs every 2 weeks. All data collected will be provided on Shell's website for the community to view. Now, we heard your feedback from prior community meetings, and we took the decision to begin the program early. So I'll share that information on how to access the data in one moment. Our leak detection and repair, or LDAR program, is one of the most restrictive in the US. We monitor more components and more frequently than are required in the Gulf Coast. For example, monitoring cogen and our natural gas pipeline. During the first year, we anticipate monitoring about 180,000 points. Volatile organic compound detectors, also called a photoionization detector, and forward-looking infrared cameras are used to detect leaks from components such as valves, flanges, connectors, seals, pressure relief devices. To access Shell's fence line monitoring program, first you go to our website, which is www.shell.us/poly-E. Next, click on Fence Line Monitoring Program. It'll be on the right. Then Passive Air Monitoring Systems Data. At the bottom left of this page, you'll find links that take you to the data itself. There's also a documents page which explains more about how to read the data. Now, if there's any questions, you can call our number, which is 844-776-5581. And you can also email us at shellchemicalsproject@shell.com. We really want you to have this information because protecting the community, our people, and the environment is Shell's top priority. This mindset is critical to the way Shell operates, and protecting the environment is key to maintaining our license to operate.
Thanks, Kim. My name is Mike Mitchell, and I would like to say good evening to everyone tonight on the call. And this is my first opportunity to join the virtual community. Again, I'm the Emergency Services Coordinator. I've been with Shell 15 years, and I'm also a 40-year emergency response professional. When I started with Shell, I started in Louisiana at one of our facilities called Norco, serving as the Emergency Response Manager for about 6.5 years before moving to Shell Global Solutions with an opportunity to work in our Center of Expertise for Emergency Response. I arrived here just a little over a year ago, and I am really excited to be part of the Emergency Services Organization, the Shell Polymer family, and certainly also to let everybody know I've really enjoyed living locally here in Beaver and enjoying a lot of the restaurants in Beaver and the surrounding communities. It's been very exciting. And like others have done, on the next slide, what I'd like to do is kind of give you a little bit of an overview of where the fire station is located, a little information about the fire station, and in continuing slides, a little bit more about the emergency response organization that we've put together here at Shell Polymers. So on the screen, certainly you can see that we have a large fire station in the upper photo there. As you kind of look down below in the red circle, you can kind of see where we're located. So certainly on the west, southwest side of our facility. We have a fire station and a medical clinic inside that building, about 16,000 square feet with double deep bays where all of our equipment is housed and ready to respond. And as like most fire stations that you have out in the communities and surrounding cities, we have offices and training rooms for all of our staff that we have here on the site. In our medical facility, we have 3 medical exam rooms where we can treat first aids that could come about. Our staffing, so we have a fire brigade, so like a regular fire department, and they're divided on 4 shifts, just like our operators. I'm the first emergency response coordinator. That's a full-time position for me. And in addition to me, we have additionally 4 shift team leaders. They're full-time, employed by Shell. And now we've actually increased up to 16 technicians. So we've added a few staff. And in addition to our full-time brigade that we have here, we have 47 volunteers that make up our full organization. And those volunteers come through us from our operators down on site that actually work in the operating units and provide, again, additional levels of numbers for our emergency response team. So what I'd like to do is on the next slide, kind of give you a little bit of information about some of the training and competencies that take place to be a part of the emergency response organization. So again, initial training, just like all firefighters in the community, they've learned firefighting. Some of us came to us with some already great fire training. We provided some additional industrial fire training at schools either locally here at BC3 or also at Texas A&M, where we have a corporate fire school. So each of our full-time members, they attended very regularly. All of our volunteers attended those fire trainings, those industrial fire training opportunities. In addition to firefighting training, because we do a lot of other things. We trained all of our first personnel in hazardous materials technician level training, both full-time and our volunteers. We're training our response action team. Those actually go to Colorado, to Pueblo. We're sending some teams out there. We just had some teams come back, and those are for rail and road transportation emergencies. Certainly, in addition to firefighting and hazardous materials, rescue. So we've trained our team with a lot of training on rope rescue. So from rescues at heights, again, confined spaces where work may be going on to ready equipment or in the future work on equipment. So in addition to the rescue part of it, our team is trained for medical responses. So anything from heart attack, somebody cutting themselves, slip, trips, and falls. Our team makes up of some EMTs. We actually have some paramedic as well as EMRs, our emergency medical responders, on our team. So in addition to that initial training, there's always ongoing activities that take place. Some of our teams are doing weekly activities as well as monthly things, quarterly training. In addition to actual training, we do drills, readiness drills in our various operating units so that we're prepared to understand what type of emergencies that could occur and how we can effectively respond to those emergencies. So we've been conducting a lot of those readiness drills to help everybody get coordinated and be more comfortable about those responses. Certainly on the right screen, again, one of our team members and showing some love there with the heart. Again, we do have an Emergency Operations Center, or EOC. We've been conducting some training, actually started back in December. This past week, we've had some additional training of our various teams that we have. And our Emergency Operations Center is, we have various disciplines on our site from our managers that come together and take some initial training. They serve a rotation of on call for 1 week at a time because we have 5 different teams. And during that time, if they're needed to be called in for weather events that could occur, we can summon them to the site if they're not already here. So we had face-to-face training, some scenario simulations, and then we'll continue on a rotation for quarterly activities going forward. So what I'd like to do on the next slide is kind of give you a little bit more idea, some of the things not only our full-time staff does, but our volunteers. Yes, we can all understand we make responses just like the community fire department. We do a lot of training, as I've mentioned before, a lot of the initial training and ongoing training. In addition to training, we have apparatus, which in just a little bit, I'll kind of show you some of the specialized equipment we have here on site. So we do a lot of readiness training to make sure that piece of equipment and the variety of pieces of equipment we have are ready to respond. We do unit and building familiarization. So as you saw in some of the earlier slides, the variety of units, we're out in those areas, becoming familiar with those, developing plans for those areas. And then just like communities, we have buildings as well. So our teams are becoming familiar with a variety of things inside the buildings, the alarm systems, the sprinkler systems, and so forth. And most like in your community, when you go through buildings, you see fire extinguishers. Well, not only in our buildings, but our operating units. We have over 1,200 fire extinguishers that will be on site, and we require, regular testing of those and inspections of those. Our team, as well as some of our operations teams, will be looking at those to make sure they're in place and ready to go. In addition to fire extinguishers, just like you may see in gyms and other locations, we have AEDs, or automatic external defibrillators, placed throughout our site, as well as on our team vehicles. So if we have to respond to cardiac situations, we're capable to do that. In addition to some of the things I've already mentioned, we do surveillance rounds. So we're around, certainly around the site, looking, listening, trying to catch things before they would materialize. So they spend some time out in the field. In addition to the things that we do on site, we've got one here that we show on the right-hand side of the screen, where we last year participated, as we've done even in previous years, is a smoke detector, CO detector giveaway, and that took place up at Beaver County Mall. Again, we got to meet a lot of folks, got to hand out some detectors so that you could take home, put in your home, and just like the alarms here that I'll talk about in a little while, alert you to let you know something's going on. So we really enjoy being out in the community. So what I'd like to do is jump to the next slide, kind of give you an idea of some of the specialized equipment that we have. Just like most communities, we have fire trucks, we have ambulances. Again, these are industrialized for the specific applications that we have here. We again have a rescue and hazmat vehicle. We have a pumper there over on the right-hand side. We have a large aerial apparatus in the bottom left. And then something you don't see a lot of times in the local community is what we call a quick attack pickup. It's a smaller pickup truck, very versatile, very easy in areas to get into tight areas that if we have to. So again, these are our fleet of vehicles that we have here, and all of our training is surrounding even these pieces of equipment. Our teams have to learn how to drive them, certainly operate them. And some of our shifts do some specialized maintenance on some of those. Well, just like with all fire trucks, you need a fire water system. So on the next slide, I'd kind of like to give you a little bit of information on our fire water system. We have a very robust fire water system here at the site. There's 3 fire water pumps. Each of those pumps are capable of 3,000 gallons a minute. And again, we do have some jockey pumps that just maintain some system pressure. And then throughout our facility, just like that you see out in your neighborhoods, we have fire hydrants. Well, on our site here, we have 150 fire hydrants. And in addition to the physical fire hydrants that you may be used to, this picture on the right shows a fire water monitor. These are ready to go. Fire water is piped right to them, specialized nozzles so that they can move them around, direct them around for any activities that we may see and be able to handle. What I'd like to do, as I mentioned earlier, when we were talking a little bit about the smoke and carbon dioxide, CO2 detectors, I'd like to kind of talk about our alarms a little bit on the next slide. So with this, we have what's called a public address and general alarm, or PAGA system. We have a series of speakers located around in our operating units, throughout our buildings, out in our rail yards. And with this system, it is possible to quickly provide information verbally, if need be, to the site with instructions on what they may need to do, to either muster something or move away from a particular area or evacuate a certain area of the facility. And this could be even for weather events that would be pending in our area as well, to help keep our site safe, just as other systems are out in the community to do some of those. We'll be developing a routine testing plan, and then that will let you know when that'll be. So some sort of regular frequency, whether it's monthly, that we would be testing that system so that you would be aware if you were hearing those systems on those certain days of the week and those certain times. It's just routine testing that we want to be able to conduct. What I'd like to do is kind of talk a little bit on the next slide. There's been some questions about evacuations that people have around questions for our site. So our facility is not required to provide a full scope, if you will, of evacuation plans for you in the community. Certainly, we're following federal guidelines. Some facilities have to provide a physical evacuation plan, but what we actually do is we work with Beaver County Emergency Services. And again, should there be a situation that we would be recommending to the community, we would give that information to Beaver County. And with that, they would have the use of their mass communication system that they can actually call you. Some people call it like a reverse 911 system. And again, many of you have signed up for that. We've kind of given you the web address for their system. And as I have, and most of our staff have, We encourage everyone to actually log into that system, register it, so that emergencies, either weather related around our community or certainly at any of the industries, can be given to each and every one of you through that process. So we encourage you to please take a look at that and sign up. What I'd like to do is kind of give you a little bit of overview of some other things that we do, some pictures. This was just one picture of the group that went up to Beaver County Mall and was part of the giveaway up there with some other folks. So this is just some of our staff, certainly not all of our staff that we have. And again, they were enjoying the opportunity to talk with the various folks in the communities and during that handout. And on this next slide, what I'd like to do is just kind of give you an idea. We were talking earlier a little bit about the training and competencies, and many people see their local fire team in their bunker gear and so forth. Well, in addition to those fire protective clothings, we have hazardous materials types of clothing. This was some examples of some of the training that took place here on site. And just kind of giving you an example of some of the extensive training that our team goes through to be ready for any type of emergency that we have here on site. So what I'd like to do is turn it back over and certainly thank everyone for giving me this opportunity to address all of you out there. So thank you.
Thank you so much, Mike, and thank you to the entire team for your presentations this evening and sharing with the community those things that you all have taken the time to write to us and call us about and ask those questions. We're glad to put that together in a presentation for you this evening. And now we would like to take some time to answer your questions that you've shared with us tonight. We also want to share with you that all of the questions that you've asked from our prior community meetings can be found on our website at shell.us/poly-e under the question and answer section there. And we'll share that information with you in a summary slide after all of the questions so that you have that and you have all of those ways to contact us and you don't have to worry about it being written down. And of course, this presentation is being recorded too. So if you miss that screen, you'll be able to come back to it later as well. So the first question that we have this evening is for Bill Watson. Bill, one of our viewers is asking, will the 600 jobs that you have for the permanent facility be filled with local workers or people brought in from other states?
Great question, Shannon. So the overwhelming majority of our workers are from the local area. Not all, of course. We've got a number of folks who've come in with a lot of manufacturing experience to help, build up our systems and get everything ready for startup, myself included. But the majority of our folks are from the local area.
Okay, thank you, Bill. And the next question is for Michael Burke. And the question is about light and what the lit facility will look like when we're operational versus in production. So the question is, what will the light from the plant look like in production in seemingly the brighter phase that we have now during production versus operation in the future?
Sure, no, wonderful. So a lot of the, what I'll say, ground level type light apparatus that are there for supporting the 24/7 construction activities, those will be demobilized as construction finishes. The ones that are probably more visible to our surrounding community, those are driven by FAA regulations. And we've actually gone back to the FAA and our permits, and we're reevaluating what we can do. So you probably notice in many areas of the plant where there was previously a bright light strobe, those have been turned in compliance with our permit back to a dimmer, at least from a ground level, red strobe light. And our commitment is to continue working with the FAA to understand any other opportunities we have in order to minimize some of the light impact in the surrounding community. And that's currently taking place and will continue in the coming time in order to understand what opportunities we have.
Thank you, Michael. And the next question we have is for Bill. And Bill, this is in regard to the portion of your presentation around the sulfuric acid spill that took place on site. Why would a flange fail have happened with installation being new in place for approximately 2 years, with fluids generally not circulating yet on a large scale?
Thanks, Shannon. Yeah, another good question. So a flange can fail. There are a number of reasons why a flange could fail. It could be a gasket issue. It could be a flange face issue. It could be a torquing issue. So the key thing there is we always investigate something like this to ensure we understand what the cause is, and then take the appropriate action to ensure it doesn't happen again. And that's really what, you know, our commitment to being a good neighbor is all about.
Thank you, Bill. And the next question that we have is for Kim. Kim, can you share how a flare that combusts material is good for the environment?
Absolutely. So the process of gathering materials and sending it to a flare and combusting it at 98% destruction efficiency means that that's 98% of what would have been emitted to the atmosphere that now isn't. And so the remaining 2. So keep in mind our thermal oxidizers are at least 99.9% efficient. So that's what flares do for us.
Okay, thank you. And the next one is for Mike Mitchell. And the question, Mike, is considering some of the other facilities in the area and the evacuation plans they have that everyone is comfortable with, how is it that this site doesn't have that same requirement?
Yeah, thank you, Shannon. Great question. Again, as you know, there are facilities like our pipeline facilities that run all around us. So we're very similar in natures to those that, again, they're not required to have those. But I think the important part for us to understand is when we recognize that there's something that's going to impact our community, we're going to be working with Beaver County as we send them information to recommend something. And maybe that's just to stay in place where you are, or again, provide you information about what may be going on. So evacuations aren't the only part of it that we will be communicating to Beaver County.
Thank you, Mike. The next question we have coming in, I think that we'll probably send this to Michael Burke. And it is a question. I've been seeing smoke coming from a high tower in the area of the high pressure flare. Is it active?
Yes, so to answer the second part there, yes, the high pressure flare, the pilots are lit, and it is, if necessary, available. Now, we have not inventoried hydrocarbon. The only hydrocarbon we have is the supplemental natural gas that goes to the high pressure flare if it's required, in order to promote the right combustion environment, as well as the pilots, as Bill showed in the FLIR video or the infrared video. As far as the smoke, again, not aware of any smoking, but you will typically see, particularly depending on weather conditions, humidity. So this morning is a prime example, it was pretty high humidity. You may see a plume of steam. And again, that's water vapor, that's not smoke. And that water vapor is injected, the steam is brought to that flare tip in preparation if the flare is needed, to promote the right combustion conditions so that we minimize any impact on our community, on our site, on our employees, and we utilize that flare control device in the most efficient manner possible.
Thank you, Michael. The next question we have for Bill, are Shell employees or management required to live within a certain distance from the plant?
Great question, Shannon. So no, there's no hard rule, though any of our leadership that's part of our emergency operations center, they've got to be within an hour's drive of the site. But primarily, you know, folks are going to be even closer than that if they come to site every day. But there's no hard and fast rule, no. I live in the county. I think a lot of our leadership does, as well as, again, in the local surrounding areas. So, yeah.
Very good. Thank you. The next question is for Kim, and it is, I heard the airshed in our area will actually get better in time with the plant operating, but how is that going to happen?
Well, the regulators have set the National Ambient Air Quality Standards, and that is what sets the air quality for the region. We can't exceed the NAAQS. We have our potential to emit that has been permitted in our air plans approval and eventually in our Title V operating permit, and we have to stay below those limits.
Okay. And the next question, I'm not sure who to direct it to, so I'll put it out there and we'll see which colleague may be best suited. And if you know that's not today, then it is something we'll absolutely put on the website. And that question relates to how much gas does the facility plan to process per day, and are there operational minimum and maximum limits?
I'll take that, Sharon. You know, long term, the notional rate is in the 100 to 120,000 barrels of ethane per day into site, and then convert that into polyethylene. As far as minimums, maximums, the maximum is set at kind of that 110, 120-ish. And the minimum, we do have what we call a turn down. And that's what we view as, you know, the safe minimum operating, and that's about 40% of that maximum, 40, 50% of that max operating rate. So yeah, I think that maybe answers the question, if I'm not.
Okay, yeah, that sounds good. And if it doesn't, for the helpful viewer that had posed that to us, feel free to send us some information, and we'll follow up with you with an answer that may be even closer to what you're looking for there. Also, I think this question goes to you, Michael. You said the railroad cars are washed between product and that the water is recycled. But what happens to the water after it becomes potentially contaminated for reuse? Where does the contaminated water go?
Yeah, so contamination is an interesting question because it's predominantly used to wash polyethylene. So what we do is the bulk of the water, we separate off any remnant polyethylene debris or other debris that may be in the car, and we recycle that. Then that polyethylene debris, which is wet, is placed into a drying bin, and the water that's removed from that runs through our wastewater treatment facilities where it's processed and then meets the permit requirements for discharge into the Ohio River.
Very good. And the last question that we have tonight is for Kim. And Kim, the question is about Operation Clean Sweep. And it's noted that we didn't mention it this time, but have mentioned it in previous presentations. Can you share how Operation Clean Sweep works on the site as our site heads in toward operation?
Sure. Operation Clean Sweep really starts at the leadership level. So it's incorporating the importance of the program in everybody that works there from leadership down. And then it goes to production, for example, operating permit or operating procedures. It goes to maintenance, housekeeping procedures, etc. And then training people is a very important aspect of it. People need to know what the requirements are, why the program is important. And of course, polyethylene is a marketable quantity, so it behooves us to collect it so that we can resell it. And so there are a lot of different layers to the program. We have all taken the pledge, which means that we're all dedicated to doing everything that we can to keep polyethylene out of the environment and in its marketable state.
Well, thank you so much, Kim. I know we're just at about time for this evening. If your question is not one of the questions that we got to this evening, we certainly will answer your question online. So know that as you're entering those questions in, we are receiving them. We will answer them online. We invite you to go and look at the questions and answers that perhaps you and certainly your neighbors have asked us about a variety of topics on site. And so our contact information is posted here for you. And we'll pause here for a moment so you can take that in or certainly look back on it on the recording. And as always, we thank you very much for taking the time to call us, to email us, to ask your questions. And we really appreciated the opportunity to share our site story with you tonight and to have the opportunity to talk with you. So thank you for taking the time out of your evening to join us. And we hope to continue this dialogue and that you'll join us again. Have a wonderful evening.